Hi, and welcome to Integrated Science, where today we are going to be adding on to talking about our metric system and applying that to making conversions, meaning taking something from either centimeters and moving it into meters or meters into kilometers. And we're also going to throw in just some other ones that we're kind of comfortable with to kind of get used to it, meaning our imperial system. So we might talk a little bit today about feet, inches, pounds, ounces. But the idea behind it is that there's a real easy way to take our units and convert it from one unit of measure to the next. And you'll hear this called dimensional analysis, or sometimes it's also called factoring. And so you've probably done this before and you can probably do it in your head. So if you think about what we're going to be talking about, it's just taking one conversion and moving it into the other. So if I say how many seconds are in a minute, you should hopefully think 60. Or how many days are in a week? There are 7 days in a week. So those are just different types of conversions. They mean the same thing, and that's what this is we're just taking one unit of measure and saying, okay, we're going to move it into this next one to sometimes make it more manageable. So if we're once again kind of looking at scale values, when we're in class, we'll be looking at different things by measuring the distance of objects traveled, and then we may want to draw that out on a sheet of paper, but we might be out in the hallway, which is several meters long, where I'm not going to give you a piece of paper that is 10 meters long. So we're going to have to scale it down so that you can draw out things in proportion. And that's kind of what we're going to talk about. So this is kind of where algebra and science kind of connect just a little bit. So the first thing that we're going to talk about is what we call our equivalent statement. And that's what I kind of just mentioned a few seconds ago. The idea that it relates to the same amount of quantities of two different units. And so I've given the example here of 2.54 centimeters equals 1 inch. We have a measure of unit in our metric system with our centimeters, and remember those are a little bit smaller than inches. Those are kind of the little smaller hashtags, and then our hash marks on our meter stick, and then our inch. Same idea with how many days are in a week. 1 week equals 7 days. 7 days equals 1 week. Same thing here. It's just 2.54 centimeters equals 1 inch. Another thing that we can use is what we call our conversion factor. And a conversion factor is just the idea that it relates to an equal ratio. So meaning that 1 day equals 24 hours. So kind of that idea that they can convert back and forth. And so same equivalent statement, we're just now putting it in as a factor or as a fraction, if you kind of want to think about it that way. So we know that for every 2.54 centimeters, that equals 1 inch, or flip it, 1 inch still equals 2.54. They are connected somehow, and that's our equivalent statement being converted into our conversion factor. So with dimensional analysis, let me pull this all up here. What we're going to be doing is we are going to be looking at what is it that we are going to be asked to move a value into something else. And this is going to become really prevalent when we get into especially talking about thermodynamics and in our astronomy unit and our Earth and space unit, or Earth unit. I guess I just said astronomy. So there's three things that we're going to be really looking at as we move forward, and I say, okay, well, this is asking us to convert from one unit to the next. So there's three questions that you need to ask yourself. The first one is, what do I know? And we're going to underline that. I'm going to start by trying to underline that for you. The second thing we're going to be looking at is, what do I want to know? Meaning, what are they asking us to move it into? And finally, the next thing is, how do I get there? What is the equivalent statement? So back what we just talked about a few minutes ago. What is that factor that's going to be equivalent to it? So what do I know? What do I want to know? And how do I get there? So to do that, we're going to use our equivalent statement, meaning that what is it that we know is going to connect those two units. Sometimes that's going to be real easy. Sometimes we might have to look that up and try to figure out, well, what is the best one that we can kind of use. Then we're going to treat the units as variables or numbers. So once again, we're looking at our quantitative information. And then finally, arranging the measurements so that they will cancel out, meaning that we're going to show one way and how we can move it into the next statement. So let's look at our example here where it says a new baby has a weight of 7.8 pounds. And what is the mass of the baby in kilograms? So this happened actually quite a bit. I have a daughter who's 7 years old, but when she was born, she had to go to Children's. And for whatever reason, Children's Hospital measured everything, all her weight, everything in grams or kilograms. And then when I would go to the pediatrician, they would measure everything in pounds. So this is not my daughter's weight or anything, but I'm giving you an example. Like this actually happened to me a lot of times. I'm like, okay, well, all right, what is my equivalent factor? How can I convert this and make sure like they're measuring her correctly at the pediatrician's office and then back at Children's? So this is something that, happens quite a bit. So once again, new baby weighs 7.8. This is what we know, 7.8 pounds. And they want us to move this into kilograms. So we would underline this kilograms here. So a new baby weighs 7.8 pounds. What's a kilograms? We don't know the conversion factor. How many kilograms are in 1 pound? So we would have to look that information up. I'm going to give it to you. So there's our circle and there's our equivalent factor. So for every 1 kilogram, that is equal to 2.205 pounds. So what we would do is we're going to write this as once again, our dimensional analysis. So we're going to start with what we know, which is at 7.8 pounds. And we're going to write it what I call into our train track method, which is this right here. So as you can see, I got 7.8 pounds, and then I'm going to put in our equivalent factor. And the key behind this is making sure that you have your units set up correctly so that they cancel out, meaning that you almost have to cross multiply. So think back into your algebra terms. So as you can see, how I have it set up is that I have my pounds here and then my pounds down here. So when I go to multiply and divide, they all cancel out. So technically what we're going to do is we're going to multiply across 7.8 times 1, and then we're going to divide it by the 2.205. So this is how we're going to set things up. And you're probably like, I can do this in my head, Miss Sparks. And yeah, you're probably right, you could. So I kind of set it all up for us there. So there's our equivalent factor. I always like to cross out my original measurements, which in this case is going to be pounds. That helps me just realize like, okay, I know that I went from pounds to kilograms, and I'm saying no more pounds, and I'm now going to answer my question or my statement in kilograms. That's our quantitative information. And remember, if we're giving quantitative a measurement of some sort, a variable, we want to give a end statement to it, meaning we want to know exactly what it is that I am measuring. So my final is going to be in kilograms. So once again, we would end up multiplying 7.8 times 1 and dividing by 2.205, and that's going to give you 3.5. And as you can see, I've moved it into that kilograms because that's what it wanted us to do. It's wanted us to get to the kilograms. So we crossed our pounds out, ended with kilograms. Let's look at another one. This one is something that you can probably kind of just do in your head, but I want to set it up correctly to make sure that you feel, once again, comfortable with it. So this question here says, how many seconds are in 2 days? So we're going from seconds to days. And so once again, I'm going to set it up in that train track mode, which I always tell students, go ahead and just draw your line right here, and let's kind of just write out what we know. So this one here is asking us, what do we know? We want to start with what number is given to us, which is our 2 days. I'm going to write that down here. So I got 2 days, and then I drew my first line. But there's no equivalent factors there. Well, technically we could probably figure them out, but I went ahead and wrote them all out for you here. So there's actually 3 of them because we have to go from days to hours, hours to minutes, minutes to seconds. And because that's what it's asking. We want to know how many seconds. So we got to do that whole big conversion. So then we can just start kind of chucking away with our equivalent ratios here. So if I'm starting with days, because it asked me to start with 2 days, I'm then going to use this equivalent factor to help me out. So I'm going to put my 1 day equals 24 hours. Next, so I've got it now looking like this, 2 days, and then as you can see I put my days across from each other, so that means that when I go to move and multiply and divide, they'll cancel each other out. So now I've got hours, and if you think about it, the next step down from hours would be minutes. So we're going to use this ratio right here. 1 hour equals 60 minutes. To make my line a little bit longer, so I'll show you there. 1 hour equals 60 minutes. And then finally, our last one is that we want to make it all the way to seconds. So 1 minute equals 60 seconds. So there's how we're going to learn to set this up, and it's going to be really helpful. This is kind of a long one. We normally wouldn't do one this long in a layout or anything, but technically if you think about what it's asking us to do, it's asking us to take 2 times 24 times 60 times 60 and then divide it by 1 times 1 times 1. And I'm writing this kind of sloppy, so if you can see down at the bottom, all I did was take away my measurement descriptions. So I took away days, hours. So we are going to multiply 2 times 24 times 60 times 60, and then 1 times 1 times 1. So actually, once we do all the multiplication up at the top, it's going to give us our final answer there, which I think is like 1,070. Where's my final? There it is. Or sorry, I was close. 172,800 seconds. So then I rounded it up there for one reason. We'll talk about why that is when we get to sig figs here. So once again, we're just taking our top part and multiplying, 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 and then we get this number right here. So how many seconds are in 2 days? 172,800 seconds. Let's look at one more here. So I've got 360 seconds to milliseconds. And you're like, when in the world would I ever use milliseconds? Just think about the Olympics, that when they are measuring someone's speed, sometimes they'll be like, they're 1/10 of a point off, or 1 point or 2 seconds off. This is that time that would come into play. So we've got 360 seconds to milliseconds. Our equivalent factor is 1,000 milliseconds equals 1 second. So once again, we're going to set it up with what we know. What we know is 360 seconds. And then we know that for every 1 second, that equals 1,000 milliseconds. And so we're just going to set it up like this on the board. And so once again, if you think about it, all we're going to do is cross multiply. We're going to take 360 and multiply that by 1,000, and that's going to give us our 360,000 milliseconds. So we're going to practice this quite a bit just to make sure that you feel comfortable with it. This is one thing that does take a little bit of time. But I do want you to get used to setting it up this way in our factoring and labeling method, just so that we are all on the same page. So hopefully this was helpful, and we'll continue to kind of work on this as we move through the next couple of days.